Hello friends, welcome to Surya Setu. In today's video, we will learn how to calculate LT cable size using Excel, especially for ACDB to client LT panel and solar inverter to ACDB. Let's begin step by step. So point 1, standards used. We follow three main standards, which is IS 3961 for cable current reading, IC IEC 60364 for low voltage installation, IEC 60502 for XLPE power cable. These help in safe and reliable cable selection. Point 2. Project details. Here are the basic project inputs, which is ambient temperature 40 degrees Celsius and cable type. We are using LT XLPE power cable, which is refer from polycab. Okay. Then third point is cable sizing criteria. The cable sizing criteria. Cable size is selected based on load current capacity, voltage drop within 2% and the power factor which we are assuming 0.95. Point 4. Derating factor. Derating means the cable capacity reduced because of temperature grouping, temperature derating and temperature derating and the grouping factor. Here we are considering the 0.61 into 1, which is 0.61. Point fifth, voltage drop limit. For voltage drop limit, we are considering the inverter to AC switch box, which is 2% as per standard, and AC switch box to LT panel, means ACDB to LT panel, which is 2%. So we are not going more than 2%. For voltage drop calculation, we are using the following formulas. The formulas for the percentage voltage drop is root 3 into IR into length divided by 1000 into R cos phi into R cos phi plus X sin phi into 100 divided by voltage into number of runs of cable. Here we can clearly see that IR is full load current in ampere. L means length of cable in meters. That's why we are divided here by 1000. R means resistance of cable in ohm per kilometer. X means reactance of cable in ohm per kilometer. Cos phi, which is a power factor, and sin phi is a reactive power. And voltage, as you know, it is a voltage. Three-phase AC feeder percentage power loss. And we are also calculating the percentage power loss. Here is the formula for the percentage power loss. So you can check 3 into I square into R at 90 degrees Celsius into length into 100 divided by input power into number of runs into 1000. So I is a current, full load current in ampere, length of cable in meters, which is noted as L, R is resistance of cable in ohm per kilometer, and number of runs. Now, point 7, input data. Here we are Here I am taking one example. In this project, inverter size is 150 kilowatt in watt, which is simply multiply by 1000. So we are getting the watt value. Rated voltage, which is 400 volts as per the inverter output, and you can check on data sheet. Load current. This load current I have calculated manually, which is total watt divided by root 3 into voltage into power factor. Here I am considering the power factor, which is 0.95. And if you want to calculate sin phi automatically, then you can use the formula, which is sin a bracket a cos bracket our power factor efficiency as per the inverter data sheet we have considered here is a 0.99. Then total maximum length of cable as per site condition, I have considered here 5-meter cable is required for me. Permissible percentage voltage drop limit. So I am here allowed 2% till 2% voltage drop. So derating factor which we are going to consider here, which is the number of cable tray, number of cables in tray, and ambient air temperature. Because we are calculating here for air laid in air using cable tray. So here is the number of cable trays 1, then number of cables in tray are 1, and the ambient temperature is 40 degree. So here we are getting the values of that derating factor. These values I am taking from the data sheet, and I have inserted this data in this Excel file and just VLOOKUP with this cable tray input. Then cable tray requirement means how many cables I am going to lay for this system. So I have selected here is 1. If I am going to select one cable, then my result is the required cable, which is 3.5 core aluminum, is 150 by 70 square mm. Okay. Then the supply voltage is 400 volts. Cable current rating in air means this is the actual cable current rating of 150 by 70 square mm, means 150 square mm cables, 289 ampere. Total derating factor. Here is the derating factor is 1, which is calculated as per the VLOOKUP formula, and these are the reference data which is going to use for this derating factor. Then derated current capacity of cable is 289 ampere. Total current carrying capacity of cable 289 ampere. Then here we are going to calculate resistance at 90 degrees Celsius. So it is 0.264, and reactance at 50 Hz in ohm, which is 0.0718. We are getting these values from datasheet. So the total current is 228 ampere. Maximum length of cable I can lay, which is 6 meters, and number of runs are 1. The voltage drop of cable, that 0.54 volts, and the percentage voltage drop is 0.13 percentage. Here is the formula used, and we have checked VLOOKUP value. Power loss is 205.69 watt. Power loss of cable percentage is 0.14. For these all values, I am VLOOKUP with this data, and this is the main master file. Here I am getting data from the datasheet and the calculations. So nominal size of conductor I have selected from the datasheet. Then total derated factor it will calculate by our derating selection. In air, the cable's current carrying capacity in air, which is shown here. Derated current capacity means after derating how much it will be going to derate, that is the capacity. Then nominal delivery length per meter as per datasheet, then approximate reactance of cable at 50 Hz. This data, this data I am getting from datasheet. Then same for the datasheet. Then number of ampere carry each phase means for selected cable how much ampere is going to carry, that is shown here. Number of meters, how much meters my cable length, number of run, voltage drop. Here you can clearly see that this is the percentage voltage drop is going to be happen. This is the percent, this is the voltage drop of cable is going to be happen, and this is the percentage voltage drop is going to be happen. And maximum length of cable can pass from that cable. So you can check like this also. Here, the derating factor. which is number of cable tray and number of cables in tray. So this is the main data which is selected while the derating factor selection. Then another one data is ambient temperature and rating factor. So this data are used for the total calculation purpose. So friends, by using Excel and considering current voltage drop and derating, we can select the best cable size for safety, efficient and long life. Before you go, if this tutorial helps you, like the video, share it with your team, and don't forget to subscribe to Surya Setu for more simple and practical solar electrical videos. Thanks for watching. Keep learning, keep growing.